how do you count the number of fish in a lake? Number of fish in a lake. How do you do it? Does anybody know seriously how biologists do it? How they keep track? Could they use technology? You know, these sonar things that, you know, that kind of look down and see the fish? Well, it would be pretty hard because you see all these little blips moving around. They're moving. You're going to count them while they're moving, these little blips? That's not going to work very well, huh? So it's actually not technology, at least not that kind of technology. How do they count the number of fish in a lake? No idea? Nobody knows at all? They catch, tag, and release is what they do. So here, let me go to the actual question. They catch, tag, and release. In fact, let me do this. Let me go back to the number of fish in the lake and just mention this. Think with me for a second. What if you catch, I want to make this make sense rather than just me say, hey, here's the rule, move the number, do the thing. You know, math should make sense. What if you catch, I don't know, 20 fish? Well, no, let's make that 100. Catch 100 fish, tag, and release. So you throw a net down. This is what they really do. You throw a net down, they pull up 100 fish, they put a little tag on them, and they release them. So catch, tag, and release 100, or they call it capture, recapture. So they catch, tag, and release 100 fish. So there's 100 fish back swimming in the lake with little tags on because they were caught, tagged, and released, right? Say 2 days later, a couple days later, you know, let the fish all mix around. Then you catch, I don't know, suppose you catch, let me make it easy. Suppose you catch 20 at random, you know, just throw down a net, grab 20, and you find, you look them over, you find that, I don't know what, let's say 10 have tags. Have tags from 2 days ago. You know, the ones you grabbed 2 days ago. So that's this method we're doing right now is called capture, recapture. So you capture them the first time and tag them and release them, and then you recapture the second time and you look them over. You know what this is like? This is like polling. You're polling the fish to see if they have tags. That's like seeing who they're going to vote for. So real life, can anybody just look at that and tell me, I'm sure there's a couple of you that can just from that information can tell me approximately how many fish in the lake? Let me help a little bit. So you caught 100 and they have tags. So how many fish in the lake with tags? 100. We tagged them ourselves. Put them back in, right? 100. Now, later, a couple days later, doesn't matter how many days, later, whatever, a couple days later when they're all mixed around, you catch 20 and 10. You throw down a net, you just grab a small group, 20, you look them over, and hey, 10 of these are the tagged ones we did from a couple days ago. So you just did that at random. In fact, I could change numbers. Let's say you have catch 200. Well, this number doesn't really matter. Like, suppose you catch 30 and 15 have tags. My point is it's half. I did 10 out of 20, 15 out of 30, whatever. Suppose you catch 30 fish the second time, the recapture, and half of them, 15, have tags. What do you think? If I went out in the street and I said, hey, who are you going to vote for in the next governor election? You know, and there were two names, you know, and half the people told me person A and half told me person B. It'd be somewhat reasonable, at least, to think maybe the whole state's going to vote that way, right? If I just grabbed people at random, asked them who they're going to vote for, and half of them said they were going to vote for person A, then I might reasonably think that half of the whole state's going to vote for person A, right? That's what sampling's all about. You just ask a small group, and you assume it's random, so it's probably what the whole thing's going to do, right? You guys with me on that thinking? Is that a good idea? That's the idea of polling, isn't it? You just ask a small group, and you infer from that what the whole group's going to do. So if I was to go out there and walk around Fresno at random and ask people who they're going to vote for in the next governor election, I don't even know when that is, and half of them said person A, I might conclude, hey, half of the people I asked are going to vote for candidate A, maybe half of the whole state's going to vote for candidate A. It's all right, I guess. So that's what's happening with the fish. Half of the fish have tags, right? We just threw down our net the second day, the recapture, and pulled up 30, looked them over 15, had tags. So we're thinking, I just threw down that net at random, and half the fish I caught at random had tags. So probably half of all the fish in the lake have tags, right? You tracking with me? Because I just threw down this net at random, pulled them up, looked them over, 30 fish, hey, 15 of them have tags. They're all just mixed around. So probably half of all the fish in the lake have tags, right? Somewhat reasonable conclusion. So if that's true, if about half of all the fish in the lake have tags, how many actual fish have tags in the lake?
200.
Well, how many? Well, I changed the question there for a second. Sorry. How many actual fish have tags? 100 actually have tags, and we're thinking from our sample the second day that's probably half the fish, because half the fish in our little grab had tags. So how many fish are probably in the lake? 200, right? Does that make sense? Because if this is half the fish, then double it, 200. See how, does that make sense? Am I reaching you? Does that make sense? That's how they let sampling tell you something about the whole group. The little sample size indicates something about the whole group. What if I grabbed 30 and only 3 had tags? What if I grabbed 30 the second day and only 3 had tags? Which is what portion of the whole lake? Which is what portion of the sample?
10.
Yeah, 1/10, huh? 3 out of 30 is 1 out of every 10. So then I'd be thinking, hey, in my little sample, 1 out of every 10 fish had tags. So probably that's true of the whole lake, about 1 out of every 10 fish out there swimming around have tags. I know how many actually have tags. And I'm saying that's 1 out of 10. So how many fish in the lake? 1,000. That's 1/10 of the lake. Making sense? Just multiply that by 10. Now I'll give you a formula in a second so you don't have to think it all tricky every time. But you get the idea behind the formula. It's basically saying this little sample tells you something about the whole lake. And then you can just extrapolate, move it into the whole lake. That's the idea. That's exactly what they do. That's modern science right there. That's how they count the fish in the lake. That's how they count deer on the mountain. That's how they count rabbits in the field. That's what biologists do. They catch, tag, and release, or capture, recapture, it's called. They grab them, tag them, release them, grab them a week later. And they figure, half of them, so then they multiply. It's an estimate. It's pretty close. So let's try it on this exact problem. Let me give you the game plan. Well, in fact, let me write the formula right here. You have the capture, and I'll rewrite it. You have the capture. It's tag over total equals, and then recapture, tag over total. That's the formula we use. In fact, let me just write it on this other screen for you. So there's the capture, like the first time you grab them, tag over total equals, and then recapture, tag over total. That's the formula we use for counting fish in the lake. Now you might be wondering, did we just change chapters? Like, why are we talking about fish in the lake? Last time we were talking about surveys, but you see the connection probably, right? It's like we're surveying the fish. It's the same kind of math, isn't it? It's like surveying. We're going to turn it into surveys here in a minute. It's the same kind of math. All right, so let's look at the question. You want to estimate how many fish there are in a small pond. Let's suppose that you first capture 500, tag them, and throw them back. After a couple days, you go back to the pond, capture 189, of which 27 are tagged. Give an estimate of the number of fish in the pond. Okay, so basically they're going to give you 3. So there's four spots here, huh? There's 4 spots. They're going to give you 3 numbers, and the 4th spot is an X, and then you just solve. So let's give it a try. So let's take it number by number. That 500. Where does that 500 go? What you want to ask yourself is that's the capture. That's the first capture. So that's over here, the first. That's either going to be the top or the bottom of the first capture fraction, right? It's the 500. Is it the top or is it the bottom? How do you know? Well, ask yourself, are those 500 fish all tagged or not?
Yes.
Captured and tagged. Yep, them are captured fish. Tagged fish. They're all captured. They're tagged fish. So that goes in the top, because tag goes in the top, total on the bottom. Those are tagged fish in the first capture. Throw them back. After a couple days, you go back and capture 189 fish, of which 27 are tagged. So this is talking about the recapture now, right? The 189 and the 27 are all part of the go back in a couple of days. The recapture, right? The second fraction. You with me? And which goes in the top there? 27 are tagged. Tag goes in the top. The total, 189, goes in the bottom. Does that make sense? And then this is x, and then we'll solve for x. Everybody see what we did there? See how I did it? So the first time we capture, we got 500 fish, we tag them all. So that's tag over total. The second recapture, 27 tagged over 189 total. Tag over total, tag over total. And then you remember how from algebra to solve this, you just go cross multiply, probably about the easiest thing to do. Just diagonal, like that. So what do we got? 500 times 189 is x times 27. Just diagonal, multiply. Everybody see what I did there? Somebody have a calculator? I should have brought mine. What's 500 times 189?
94,500.
Thank you. 94,500. This is 27x. I'll write it the other way so it looks a little more normal. So we good to there? How do we finish solving for x? We divide by the 27, huh? Divide by the 27. In which case, can you help me out with the calculator yet again? What is it? Like exactly? Okay. 3,500. So that's and it's just an estimate, huh? It's not perfect. Just like polling is an estimate. About 3,500 fish in the lake. And this also, notice how this method's good. It would allow you to count particular kind of fish. Like you could count just trout. Because you grab a bunch of fish, ignore the ones that aren't trouts, tag the trout, put them back, catch them later, again, ignore the ones that aren't trout, and just do the same ratio only for trout, or only for bass, or whatever you want. That's exactly what they do. Everybody good with that? So on your 3x5 card for the next exam, tag over total equals tag over total. All right, now they're going to give us a bunch of these now. Let's see. Let's try to make it a little more simple. Okay, it's going to be one of these tag total problems. What we're going to do with coins. You have an extremely large jar full of nickels, dimes, quarters. You want an approximate idea of how much money you have, but you don't want to go through them all. So you decide to do capture, recapture with your piggy bank, basically. For the sample, you shake the jar, randomly draw 150 coins. You get 37 quarters, 45 nickels, 68 dimes. Black marker, you mark them. That's like tagging fish. You mark the coins. Black dot, put them back in. Second sample, 100, you get 35 quarters, 5 have black dots, 28 nickels, 8 have black dots, 37 dimes, 14. Estimate the number of quarters in the jar. They're giving me a nice hint there. Disregard nickels and dimes. They are irrelevant. That's right. Okay, so it sounds so fancy, all those words, all those numbers. It's just tag over total. Let me help you with it and show you how to cut through all the fog. It's just tag over total, first capture, second capture. We're just, instead of tagging it, we're tagging them with a black dot. That's basically what we're doing. So it's just like, and we're only caring about quarters because that's all they asked me for is quarters. So it's just for quarters only. I'm not going to pay any attention to what they say about dimes or nickels. So basically, the first time we grabbed, in our first tagging, how many quarters did we tag? 37, right? Right, because you get 150, you 37, and you tag them. So 37 quarters are marked with a black dot. Good? So we just had this big jar full of coins. We grab out a bunch of them, and we mark them with a black dot. That included 37 quarters. Also some nickels and dimes, but who cares? We're just doing quarters. So 37 quarters are the number of tagged quarters. So that's right here. Okay. And then you throw them back in, mix them all around, reach in again without looking, and you get what? The second time. 35 quarters, 5 have tags, black dots. So how am I going to write that fraction? Tag over total, 5 over 35. Everybody good with that? 5 tagged out of 35 total. The second time for the quarters only. So this is x, same thing, cross multiply, solve for x. Does that make sense? It's a way of estimating how many quarters are in the jar. Does everybody see that? Because you grab some out, marked them black, put them in, mix them around, grab again at random. You found 5 out of 35. So solve for x there. Diagonal, diagonal. 37 times 35 is 5x. Should have brought my calculator today. What's 37 times 35? Anybody?
1295.
Thank you. 1295 equals 5x. Last step to solve for x is divide by 5. And that's going to be 210 and 49, 259. 259 quarters in that jar. Is that good? You okay there? I'll move on. Just catching fish is all. Uh-huh. Or something weird?
Yeah, the part I'm not getting, I'm looking at the homework on here, and it
Uh-huh.
uses an example of K being 8,
Okay.
but where are they getting the 8? Because I see where they get the N, the big N, and the little n, but I don't see where they find K at.
Yeah. Let me just try it and we'll see. A study was conducted, blah, 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 number of lake sturgeon, whatever, using capture. Size population was a problem. Oh, okay. The study concluded the size of the population was 160,000. Okay. So I'm going to write, again, tag over total equals tag over total. This is the first time. This is the recapture second time. Let's save that 160,000. We'll come back to it. Let's keep moving. In the capture phase, that's the first phase, right? 1,900 were caught, tagged, and released. So that's up here, 1,900 on the top up there, huh? In the capture phase, see what it said? This is capture.
Yeah.
The other one is recapture. Right? It's capture, and then you tag them, release them, and you recapture them later at random, right? So in the capture phase, meaning in the first fraction, 1,900 were caught, tagged, and released. So 1,900 tagged, right? Then it says, of these tagged sturgeon, 6 were recaptured. 6 were recaptured. That's right here. Why? Because that's recapture and they're tagged, right? Those all had tags. So that's recapture tag. 6 were recaptured. Okay, now where's the 160,000 go? Is that... Well, let me see. What are they asking for? Based on these, estimate the number of sturgeon caught in the recapture. The number caught in the recapture. That's X here, isn't it? Everybody see? They're asking for the total number in the recapture, aren't they? So then that 160,000 must be the total number in the lake originally. And sure enough, that is what they're saying. The population was found to be 160,000. Total number in the lake. Does that make sense? So 1,900 tagged over 160,000 total. 6 caught in the recapture tagged over how many total in the recapture. So there we go. Is that good? Now I'm going to just go dot, dot, dot. Just cross multiply and solve for x. Same thing. They're just kind of turning it around backwards, sort of.
Yeah.
Being kind of tricky on that. All right. Off we go. You're okay? Move on. It says one implicit assumption when using the capture method to estimate the size of population is that the capture process is truly random, with all individuals having the same likelihood of being captured. Sometimes that's not true, and some individuals are more prone to capture than others. If that were the case, would the capture-recapture method be likely to underestimate or overestimate the size of the population? Explain your answer. Well, you can see I've got the right answer on there. So, but what they're saying is, think about this. This is a valid criticism of this method. This method is not perfect. There's no perfect method here. One valid criticism is, hey, whatever fish you're catching the first time and tagging and releasing, they're going to be more likely to be caught the second time because they were caught the first time. They're just the catchable kind of fish. There's some truth to that. There certainly is. It's not overwhelming, but there's certainly some of that that's true. And that's going to tend to throw your numbers off because you need them random the second time. And they're not truly random. Those fish are probably a little more likely to be caught. So if that's the case, they're saying, what will that do to your estimations? What will be the effect of that? And the answer is, it'll cause an underestimate. The total population appears smaller than it really is. Why? If the fraction of those tagged in the recapture appears to be higher, right? They're more likely to be recaptured because they're catchable fish, more catchable. So a higher recapture, then the fraction of those tagged in the initial capture will also computed as higher than the truth. Then the fraction of those tagged in the initial will appear higher. Higher. Oh, which means the denominator is lower. That's confusing, isn't it? Yeah. Yeah. So I'm going to leave it at that. That's a little bit of a tricky question. But I can explain a little. I don't want to use up too much time. So basically they're saying if fish are more, remember it's tag over total equals tag over total, right? And this is the recapture, and this is the first capture. So if this is higher, if this fraction is higher, because those fish are more easily caught, so there's more tagged fish going to show up in your recapture than is truly the average in the lake, because those are just more catchable fish. So this fraction is higher, which means since these two fractions are equal, this other fraction is higher also, right? Higher equals higher. They're equal, right? So what? Okay, so this is higher, right? The number of tagged fish, that's fixed. You can't change that. That's just how many fish you tagged. You can't mess with that. So how can a fraction be higher by messing with the denominator? What do you got to do to the denominator of a fraction to make the overall fraction higher? Am I speaking a foreign language? So you ever thought about a fraction? Take 100 over say 100 over 4. What's 100 divided by, or let's just do 20. What is 20 over 2? What's 20 divided by 2? 10. And now if I make keep the top the same and make the bottom bigger, like 4, what happens to the answer? What's 20 divided by 4? 5. The answer goes down. When the denominator goes up, that makes the answer go down, of course, huh? When the bottom of a fraction gets bigger, the overall answer gets smaller, right? You know that. Well, over here they're saying this fraction got higher. How does the answer here get higher? Well, the bottom needs to get smaller, doesn't it? Because the top is fixed. You can't change the number that we're tagged. So the only way you're going to make this overall fraction get higher is by making this denominator get smaller than it should be. And that is what? That's the total population. That's why they're saying underestimate the total population. It gets smaller. That's what tends to happen. So that was a little bit of advanced thinking about fractions and how that works. That's how a statistician would think about the fact that the fish are more catchable. That's going to tend to underestimate the population a little bit. All right. I'll move on. No more fish. Manufacturer. Hey, did you guys all get the handout from last time? I got some more here. Got some exams too, if anybody didn't get the exam back. So here's the handout from last time. Who needs it? Who didn't get it? If you have that, grab it out. We're going to talk about it. I got lots of extras. You want another one? Doesn't have with them. So we got it. So grab that handout from last time, and let's talk about some of these concepts. All right. So here we go. Manufacturer of a new vitamin decides to sponsor a study to determine the vitamin's effectiveness in curing the common cold. Now, you guys want to be wise consumers, right? This is the information age. Here is a great example of becoming a wise consumer. That's why it's my favorite chapter. It's very practical. So here we go. They do the study. They're doing a study, and I want you guys to be critical observers. Start thinking about some of the things we've talked about. Be a critical observer. 500 out of the 50,000 college students in a large city were paid to participate as subjects in this study. All of the participating subjects were suffering from a cold at the start of the study. The subjects were each given 2 tablets of vitamin X a day. Based on the information provided by the subjects themselves, 457 out of 500 of the subjects were cured of their colds within 3 days. The average number of days per cold is 4.87. So that's quicker than average, right? As a result of this study, the manufacturer launched an advertising campaign based on the claim that vitamin X is more than 90% effective in curing the cough and cold. The 90% is, if you divide 457 by 500, it's a little over 90%, so that's true. Was the study a controlled study? Explain. Now I have on the back, we're on the back now of the handout, all the information on the back is all about clinical studies. We're changing gears now. Now we're not surveying people. We're not asking them who they're going to vote for or whatever. We're actually doing clinical studies. How do they decide if a new vitamin or a new medicine actually works? How do they decide that? How do they know it's working?
We compare it.
What's that?
We compare it to a control group.
Yeah, do you know what a control group is?
Yeah, they're not given anything.
Exactly. Is everybody aware of that? Yeah, it's called, so all those terms are on here. Yeah, the way they test things clinically is they'll take some new medicine that they think is good, and they'll give it to some people and not give it to the other people. The other people are called the control group because they're helping you control the experiment, control getting to the truth, in other words, right? So one group gets the medicine, the other group doesn't, and then at the end, they measure and compare. Did the group who got the medicine, did they do better than the group that didn't? Now, why do they do that? Why don't they just give some group the medicine and just see if they get better? Why do they need to have another group that they don't give the medicine to, a control group? Why is that needed? Why? Why don't they just give it to some people?
We need to know that it's not something else that's creating those results.
Well said. Well said. Yeah. So let me write some of those terms. We'll come back to this question, but it's on your paper, but I just want to write a brief. Control group gets nothing. I don't know how I said it on the handout, but I want to say it in a way that sticks with you. Gets nothing. They get no medication. They get no whatever, right? They get nothing. The treatment group is the other group. The treatment group gets the treatment, obviously, hence the name, huh? So there's one group that gets the treatment, one group that gets nothing. So that's to compare, because if you just take a group of people and you just give them some, if you just grab a group of people and just give them some medication, and you say, hey, they got better. Well, maybe that particular cold that was going around at that time was a really weak one, for example. And you could have given them nothing, and they would have got better in a quicker amount of time. Or maybe that group of people you gave it to was just a healthy group of people, and they were going to bounce back quick no matter what you gave. That doesn't really prove that medicine did something. You see the problem? Whereas if you take a group, you break it into half this group, half that group, and you give half the medicine and half nothing, and the group that gets the medicine gets better a lot faster than the other group, then you're like, okay, that medicine's making a difference. You got to have something to compare, huh? That's what they do. That's what a clinical study is. They have a control group and a treatment group, not just a treatment group. So notice that right off the bat. There was no control group here. They didn't take a bunch of these college students and give the vitamin to half of them and not to the other half, did they? They just gave them the vitamin. No control group. Right off the bat, bad study. In other words, not likely to really tell us the truth. I don't think the company is heavily interested in the truth. They're heavily interested in promoting their product, right? That's not a controlled study. That's not a clinical study. FDA would not approve, right? They would just, that's a big joke. They would just laugh. You're just giving the medicine to people, and you're not even trying to get to the truth there, right? So first question is, was it a controlled study? That just means, was there a control group? No, there was no control group. B, list 3 possible causes other than the effectiveness of vitamin X itself that could have confounded the results. We're talking about confounding results. What could have messed it up? Well, you see my three answers here. Did you notice the volunteers were paid to participate? Right? So if a company comes to you and says, I'm going to pay you to be part of this experiment. Take our medicine, tell us how many days to get better. You're going to be somewhat likely to say a favorable word, especially if they're paying you well, right? To say a favorable word about how good their product was, right? That's going to tend to obscure the truth, isn't it? They were paid. You can't be having that. Next one. College students are not typical. Yeah, they only grabbed college students. What about old people? What about little kiddos that have colds their whole life for the first 5 years of their life? It seemed like when I had little children back in those days. Boy, I haven't been sick for like years. I mean, I'm sick every now and then, but I mean, you know, when I don't know, you guys haven't raised kids yet, maybe most of you. When you raise kids, you're like, oh my goodness, I have always got a cold for like 5 years. And we had 5 children, so somebody was always in that stage. I've been enjoying health now for like more than 5 years. This is great having older children. And I don't want any little kiddos coming to my house. No, I mean, I like little kiddos, but when somebody visits, I'm like, oh, they got kids with a cold? Honey, can we tell them to come back later? Anyway, I don't do that really, but I'm tempted to. Yes, so anyway, yeah, how about little kids? How about old people? How about something other than like college students? That's not likely to get, they pick one type of person, right? That's not a good way to get to the truth. So, and then this one, the subjects themselves determine the length of it. That is huge. Did you notice that? We're going to be talking about that. Did you notice right there that how did they know they got better from the cold? They said so. They said so. That's not very scientific. You want to have a doctor look at them and check out their temperature and feel their throat and those kind of things, right? You don't want them to go, yeah, I'm feeling a little bit better. You know, that's not. So there's a million problems with this study, right? That tend to make us think it's baloney. It's not getting to the truth. Do you know that, what's the stuff they have out there now to help you get over the cold real quick? Sort of the Z, right? Isn't there a Z one? Maybe you guys aren't into it. It's a Zy something. And then there's another one, Airborne. That's the other one. So there's Airborne, and then there's another one with a Z, I think. Anyway, you know, those, you know, it's like a boost of vitamins, and it's supposed to, well, you're actually supposed to take it before you get the cold. Like if you're around people that are going to have a cold, or, you know, you're going to go to some big event, and there's a lot of people that might be sick there, you take this to boost. Anyway, did you know, though, officially, that is not FDA sanctioned? Not that it's bad for you, it's vitamins, that's good. But it has not been clinically proven to be effective. And they say that on it, they have to. Now, we have all these laws in America, truth in advertising. It says right on there, not proven to really cure the common cold. I used to take that stuff for a while, because probably back when my kids were little, I was getting sick all the time. And anyway, I used to take those all the time, and then I think, I think that might be helping, I think it might not. My oldest son, he just like, my kids like to mock me. So he'd always say, Dad, you know that's not proven. You know that's, he would always say, that is not medically proven. You're just fooling yourself. After a while, I quit. He's right. You know, anyway, it didn't, I know it works for some people, but truthfully, it has not been clinically proven to really be effective. It's just word of mouth. That's all it is. All right, so it's important to be a wise consumer of that information. All right, so lots of problems. A surgery one. Okay, so, clinical study, blah, blah, ankle surgery. 324 individuals who met the inclusion criteria, 165 declined to participate. Researchers randomly divided 159 into 3 groups. One group received type A ankle surgery. The second group received type B ankle surgery. And a third group, you tracking with me? Received skin incisions to make it look like they had ankle surgery. But no actual surgery was performed. They cut them open and did nothing. Did you catch that? Group C, they cut them open and did nothing. The patients in the study did not know which group they were in, and in particular did not know if they were receiving the real surgery or simulated surgery. How would you like to have simulated surgery? In a 2-year follow-up, all 3 groups said they had slightly less pain and better ankle movement. But the fake surgery group often reported the best results. Describe the study. All right. So we're going to go through. Oh, this is the only question on it. Okay. Choose the. So what do they ask you? Describe as specifically as you can the target population for this study. So, all right, so do you get what's happening there? Let's talk about some of these terms. I'm going to ask a lot more than this on the question. You'll see the practice exam. But they're asking, what's the target population? What do they really want to differentiate? The green is the right answer. All potential ankle surgery patients. What do I mean? Why is that the target? Well, just think real life. What are they trying to figure out with this? Just be real with this for a minute. What they're doing this. There's two types of surgery. There's type A surgery. So they took a bunch of patients who had ankle trouble, and they broke them into three groups. And they had a bunch of them, they did type A, a bunch of them they did type B surgery, and the third group, fake surgery. No surgery at all, really. They just cut them open, put them out, cut them open, sealed them back up, didn't tell them for 2 years that they received no surgery at all. Then, and this, by the way, this isn't made up. In fact, I could find it. Where is it? It's in 13.2. This has really been done. This is not just silly little math problems. Where is the one? If I can find it here. It was done at a VA hospital in Houston back in a while ago, 80s, I think, or something, 90s.
So this is actually legal?
Yeah, I know. It sounds a little shaky, doesn't it? Yeah, no, the people had to agree, right? Did you notice 165 declined to participate? Yeah, no, they had to tell them up front. Yeah, they can't be like, you paid for surgery, we didn't really do one. Yeah, no, that's why so many, like half of them said no thanks. More than half, right? 324 showed up at the hospital and needed the surgery. These particular numbers are made up, but this really happened. And they told him at the Houston VA hospital. I find it here pretty soon. Where is it? At the Houston VA hospital one, they half of them said no thanks as well. If I can find it, clinical. Okay, there he is. I'm getting close. There it is. At the Houston Veterans Administration, it conducted medical center. Conducted the study, and the effect was actually knee surgery. So this is made up ankle surgery. Here's the real numbers. And this was in what year? Does it tell the year? This is from the New England Journal of Medicine, July 11, 2002 is when the article was written. So sometime before 2002. So anyway, at this medical, 324 people had knee problems, and they told them up front. They said, okay, guys, here's what we're going to do. We're trying to learn if these knee surgeries are really working. We want to help people. It's not just to torture people. We're trying to figure out the truth. Do these things really work or not? So they said, we'll give you, what they often do is they give a free surgery if you're willing to participate in this thing. We'll give you a free surgery, but you'll have to agree to our conditions. It's going to be random. We're going to randomly pick you three groups, and type A, type B, and no surgery at all. So you have a 1/3 chance of being cut open for nothing. And then we're not going to tell you. For 2 years, you have to agree, you got to sign that you're okay with all that, and then in 2 years, we'll tell you what really happened after we ask you how you're feeling. We're trying to learn the truth of which surgery works best, or maybe no surgery at all, blah, blah, blah. They really did this. And the results were one group received type A arthroscopic knee surgery. Second group received a type of arthroscopic knee surgery called lavage. A third group received skin incision to make it look like they had arthroscopic knee surgery, but no actual surgery was performed. The patients in the study did not know if they were receiving the real surgery or simulated surgery. Keep that in mind. Why? Why didn't they tell them?
To see the actual results.
Because of placebo effect. You notice that? It's on your sheet. Good job. Good job. It's on your sheet. Placebo effect, right? The idea that one is getting the treatment can produce positive results, right? There's been a ton of research done in the last 20, 30 years about how much our minds affect our bodies. We just commonly all know it now, huh? That was news maybe 30 years ago, right? If you think something's being done to help you, your mind can do a lot of good things for your body. We all commonly know that now. A lot of researchers uncovered that in the last 30 years, right? So that's why they got to rule that out. They got to make sure it's not just mental. Did that surgery actually do something physical to their knee or their ankle or whatever? Or was it just all mental? And how are they going to get to the bottom of that? They got to tell them they're getting a surgery when they're not. So they think they are. They got to lie to them, right? That's called the placebo effect. With medicine, they give you a sugar pill, right? Or something that looks like a pill, but it's got nothing in it. And that way they discern if it's just mental or if that medicine or the surgery is really doing something physical to your body. They got to rule out our minds because the minds are very effective in healing our bodies. So, okay. So anyway, all the patients who participated in the study were evaluated for 2 years. Like I said, they didn't tell them for 2 years. after the procedure. Here's the actual real-life results. This is the 2002 New England Journal of Medicine. In the 2-year follow-up, all three groups said they had slightly less pain. All three groups, even the ones with fake surgery. Slightly less pain and better knee movement. But the fake surgery group often reported the best results. So what does that mean? The surgery did nothing physically, right? I mean, the ones who got no surgery did better than the ones who did. So in other words, quit cutting people open and doing whatever this particular kind. They learned from that these knee surgeries are doing virtually nothing. They're not really physically helping the knee, right? That's what they learned. All right, so that's real life, Houston, VA. So this is made up kind of thing. What's the target? The target is like, what are you really trying to figure out with this? You're trying to figure out, does this ankle surgery, all potential ankle surgery patients, that's the goal, is how you can help all people who have knee surgery, or in this case, ankle surgery, in the future. That's the goal. So I'll also ask questions on the test. You'll see the practice exam. Like, is this a placebo? Is there a placebo? What's the placebo? And that's the, telling people, cutting people open, but telling them they really had surgery, right? Control group, placebo effect, treatment group. Yeah, so you got all those words. Oh, this is called, let me mention this. This is called a blind study. Why? Because the patients don't know, right, whether they got the real surgery or not. They're blind to the truth about whether they got the real deal or not. That's on your sheet as well, blind study. Now there's, let's go on. We'll see another one like that. Any questions on that one? Like good? All right. Okay. Clinical study was conducted. Effectiveness of neck surgery to cure a specific type of arthritis. 323 individuals met inclusion criteria. Blah, blah, blah. 173 said no thank you because, they're going to maybe not get the real surgery. Researchers randomly divided the remaining 150, 3 groups. One group received type A, type B. Now, so it's the same thing. Same thing as the last problem. Patients in the study did not know which group they were in particular did not know if they were receiving the real surgery or simulated. So that's all the same. 2-year follow-up, all 3 groups, everything's the same. There's nothing different. I don't know why I read all that. Was this study a controlled placebo? Yes. Yes. There was a control group receiving the sham surgery, the placebo, and 2 treatment groups. Does that make sense? It is. There was a control group. So that is a controlled placebo experiment. Are those words making sense for you? I probably should put these up without the answers already there. It might help you. But that's okay. I'll just keep it as it is. Does that make sense? Because I'm doing whatever I can because this seems so straight ahead, doesn't it? But I'm telling you, people have trouble with these words on the next exam. So I want to do whatever I can. Is everybody really grabbing those words? Is that making sense? You wouldn't be fooled on the test by these other options. Right? So control means there's a control group. Placebo means somebody's getting a fake. Right? So it's controlled placebo. Next question. Describe the treatment groups in this study. Like, who is the treatment group? Well, those are the ones getting something real. The first treatment group is type A. The second is the ones getting type B. That's the treatment group.
Wait, you said placebo is someone's getting a fake surgery?
Fake. Placebo means fake. Exactly. Good. Placebo means fake. Exactly. Is that good to there? Let me move on. C and D. Okay, and then what is C asking? Could the study be considered randomized control? Is it randomized control? Yes, the 150 patients were assigned to treatment group at random. It said up there, the researchers randomly divided the remaining 150. So they randomly split them up, rolled dice or whatever, a random program, broke them up. So it's randomized and it's controlled because, there was a control group who got nothing, right? So some group had to get the fake surgery. They're the control group. So we know if the surgery is really doing anything at all. Right? That's control group. Was this experiment blind, double blind, or neither? It's blind. Why is it blind? What does that mean, blind? Yeah.
Because they have a placebo group and they have an actual group. So
yeah.
Technically it wouldn't be double blind because the one has the real thing and the other.
Well, actually, I haven't even explained double blind yet. But you're right about blind because there's a placebo group. That's exactly the reason. Everybody good with that? There's a group that, because the people don't know. Yeah, it's blind because the patients do not know if they're getting the real surgery or not for the placebo effect, right? Now, what's double blind? Does anybody know that one already? And nobody knows. Well, you can't quite have no, but somebody's got to know, or how are we going to know what the results are, right? But you're right on. You're generally right, Johnny, what you're saying. It has to be the doctors don't know. Now, there's always an administrator over the whole program that does know. Otherwise, you can't even keep the data, right? You can't learn anything from the experiment. But you're right. So double blind would be when not only the patients don't know, but the doctors don't know. Let me write that. Double blind, also doctors do not know. Now, in this case, no, why would they ever do that? Why would they ever want the doctors to not know? Well, a lot of, not for the surgery thing, but if you're giving medicine and you're trying to see if somebody's better from a cold, or especially they did this with polio, when they were curing polio, the vaccine, what's it called, the Salk vaccine, right, when they first did that in the 60s, 50s, something like that, and they cured basically America and all North America, all the civilized world basically, of polio. The trick with polio and a lot of things like it is you give somebody the treatment, and then the doctor looks at them months later and decides if they're getting better from polio or not. It's kind of a judgment call. It's not clear cut. It's not 100%. So if the doctor knows in his or her mind, oh, this person got the medication, they're going to tend to think, oh yeah, they're getting better, too much. And if they didn't, maybe not. So in those cases, they also have the doctors not know which patients actually received the real medication and which ones just got fake sugar pill stuff. So the doctors can come in and just straight ahead look and say, yeah, this person's getting better, they're not getting better, and write it down. And there's an administrator over the whole thing that really knows who got it, who didn't. So sometimes they need to do that, double blind. Doctors don't know, patients don't know. Only some administrator knows. Now, they couldn't do that in the surgery case, right? The doctor knows whether he did a real surgery or she did a real surgery or not, right? They don't want to blindfold the surgeon. That wouldn't be a good plan, right? I'm not sure whether I did that surgery or not. I just went in there with that knife and something happened. I don't know. All right, no, they can't do double blind for surgery. All right, so there's the questions on that. Okay, so following excerpt refers to a landmark study in 1896, Denmark, Johannes Fibiger, I don't know, who went on to receive Nobel Prize medicine in 26. The purpose of the study was to determine the effectiveness of a new serum for treating diphtheria, a common and often deadly respiratory disease in those days. Fibiger conducted his study over a one-year period in one particular Copenhagen hospital. New diphtheria patients admitted to the hospital received different treatments based on the day of admission. In one set of days, called the even days for convenience, the patients were treated with serum daily and also received the standard treatment. Patients admitted on alternative days, called the odd days, received just the standard. They didn't get the serum. Over the one-year period of the study, 8 of the 239 patients admitted on the even days and treated with the serum died, whereas 30 of the other ones died. Yeah. All right, so to get the big picture, so let me try to lay out the crucial facts there. Basically, this really happened. This doctor at this hospital thought he had something that would help diphtheria. And so he just decided, every Monday, Wednesday, Friday, I'm going to give them the serum, and every Tuesday, Thursday, Saturday, not, or something. Just whoever comes in off the street on those different days, half the days I'll give them the serum, half the days I won't, and I'll just keep track, see if this thing's really working. That way, he set up a control group, right? Half of it's getting the special serum, half of it's not. So broke them into 2 groups, and then here was the results. Over the one-year period, the 239 got the serum. 239 that got the special serum. How many died? 8 died. And the 245 no serum, the 245 that did not get the serum, 30 of them died. So a lot more, more than triple, almost 4 times as many died among those not getting the serum. So it seems like the serum is really making a difference, right? Those are strong results. That's what convinced everybody that his serum was really doing something physical. That's a clinical study. So describe the sample for Fibiger's study. Choose the correct answer. So what is the sample? What is he sampling? Well, that's the 484. That's 239 plus 245 is what that is. 239 plus 245 must equal 484. That's the 484 people he looked at. That's the sample. B, is selection bias possible? No, it's unlikely. since humans were not involved. Right? Selection bias is when you tend to pick a certain kind of person or not based on your own biases. There's no chance for that here, because that'll throw results off, right? If the doctor was just like, hey, doc, just go out and pick whoever you want, give them the serum, and then pick some other people to not give them the serum. Well, we all have our biases, and that doctor might pick certain kind of people that he or she likes to give the serum to, another kind that they don't. And I don't know, it might be more healthy people or vice versa or something like that. It's going to throw off the results, going to bias the results. But there was no human element to this, right? It was just literally everybody coming into the hospital on a Monday is getting the serum. Everybody on Tuesday is not getting the serum. So that made it random. That kept the biases out of it. That's important when you want to get to the truth in a scientific clinical study. Is that good? That all making sense? All right. I'm going to go on to 13.3.